All right, welcome to another day in the classroom. Here we're in Algebra 2. Today is boys hockey section quarterfinals day. So hopefully the pep band is ready to drop it like it's hot. Yep. And we are going to go back a little bit and talk about graphing and the transformation stuff like right 2, up 5, vertical stretch, all that jazz, reflect over x, all that stuff we're going to do with a different parent function. So our new parent function is going to be the square root function, and that's what this page says. We're going to talk about f of x equals the square root of x. Sorry, we had some technical difficulties there. Seriously, gosh. All right, next page. Let's review what we learned earlier in the year. So to start, I guess I'll go back to where we started. We moved everything that wasn't with the x to the y side. Remember this? I said remember this?
Yes!
Good. Okay. All right. They're engaged. So let's move the plus 4, because anything that is not inside the parentheses to the power or to the absolute value or square root or whatever, that's not with the x. So let's move it over, and that's actually affecting the y. So this would be y minus 4. And then if I move the times 2 over, it ends up being a divide. And so I end up with this. And that, then we can interpret this now as what's happening to the horizontal stuff, the x stuff. If it's minus 3, that moves it to the right 3. Okay, if it's minus 4 on the y, that's going to move it up 4. And if it's a divide on the y, divide is a stretch, remember, so that is a vertical stretch. You could say by 2 as well. I'm just going to say vertical stretch. Got it? Okay, and then at the end of the unit, a lot of you probably didn't have to move everything over, and you could just look at it and go, well, the inside we do the opposite of right and left, and outside is the same of up and down. So you could maybe look at this one. Oh my gosh, this thing is just trash today. It so doesn't want to behave. Watch this. Oh, I guess it's fine. Okay, stop messing with me, smartboard. Got a mind of its own. Look at that, though. I want to push on the red one, and why? This is hype square. So this one's gonna go right 2. Oh my gosh, I'm trying to write. Oh, I can write better at home. Right 2, and then this is gonna go down 1. And it is gonna be a horizontal stretch. What's the question? Put everything with the y, meaning like move it over to the other side. Some people like to, gosh, this is just driving me nuts right now. Some people like to rewrite this as like y plus 1 equals absolute value x minus 2 over 3, like that. And then everything's opposite, like the y stuff side is opposite, so it'd be actually, if it's plus 1 over on the y side, you actually go down 1, All right, then this one is a little sneaky because nothing is actually with the x. So if I rewrote this one, it would be y plus 1 divide by 5 equals x cubed, because that 5 really isn't to the third power, so it's not acting on the x. So this one is going to go down 1, and it's going to be a vertical stretch, which is going to make it a scarier roller coaster. It's going to be steeper, it's going to go up faster, it's going to be skinny maybe. Say skinny. All right, keep on trucking. This is the new parent function we're going to work with. It's a square root of x function. So if we take a look at how we get this function, if you put a 0 in for x, the square root of 0 is 0. If you put a 1 in, the square root of 1 is 1. If you put a 4 in, the square root of 4 is 2. If you put a 9 in, the square root of 9 is 3. And so that's how you end up getting the values of the square root of x. The thing about the square root function is that it has a restricted domain because you cannot have the square root of a negative. So because you can't have the square root of a negative, the domain is restricted, in this case, on the parent function, to be x greater than or equal to 0. Okay, so we're going to have to pay attention to the domain and the range. If you look at the translations here, again, this just reinforces if it's adding inside the square root, it's going to move it to the right and left. It's grouped with x. If it's outside the square root, it's actually with the y that moves it up and down. Okay, so if you're not sleeping by now, keep moving along. Let's build a little table of values here, and let's sketch a graph. So, what values for x should I pick for my table of values? Normally when we make a table of values, we're like, all right, let's pick some negatives, let's pick 0, let's pick some positives. But we can't pick negatives here because it's the square root of x, and if we pick negatives, that would give us a non-real number. So let's start with 0. Square root of 0 is 0, plus 2 is 2. Okay. 1. Square root of 1 is 1, plus 2 is 3. Now, should we use 2 for the next one? No, because the square root of 2 is going to be like a decimal. It's just, you could use it, but it's just not happy. 4, good. 4, square root of 4 is 2, 2 plus 2 is, okay, the next one should we use? 9, now we're cooking with gas. Square root of 9 is 3, 3 plus 2 is 5. Okay, so if we plot those points, we'll have 0, 2. The smartboard seemed to have calibrated itself. It's now back to normal. 0, 2, should knock on wood. Behind there it is. 1, 3, 4, 4, and 9, 5. I think that's 9. So there we go. Now we got a little curve. It's kind of like a tipped over parabola, only half of it. Kind of like a tipped over half of a parabola. If I graph the parent function would be like 0, 0, 1, 1, 4, 2. Parent function would look something like that. And so what essentially happened to this graph was it was shifted up 2 units. Each point shifted up 2 units. Isn't that right? And that's what the translation is, right? It's plus 2 outside of the x, so it actually goes up 2. Okay, a little different one. This one's going to have a horizontal and vertical change. Do a little table of values. What value for x should I pick first? I'm going to pick -1. Just because I want to know where it's going to be 0 in the radical. And this brings up a good point. What's the smallest that the square root of anything could be? 0. So, hi. The square root of 0 ends up being 0, but the square root would be 0 when x is -1. So if I put a -1 in, I'm going to get a 3. Okay, now to get a 1, I'm going to put 0 in. Why not? Because 0 plus 1 is 1, and the square root of 1 is 1, and 1 plus 3 is 4. Roasted. All right, so that works. The next one would be 3. just to keep our happy little values. 3 plus 1 is 4, square root of 4 is 2, 2 plus 3 is 5. Next one is 8. 8 plus 1 is 9, square root of 9 is 3, 3 plus 3 is 6. Just trying to keep the values nice and integery. Question? Go ahead. No? Okay. So then negative 1, 3 is kind of my smallest value. 0, 4, 3, 5, and 8, 6. I just realized we forgot to talk about domain and range on the last one. So from the parent function, this parent function would be something like that, right? So this one has moved to the left 1 and up 3, right? Which makes sense if you look at the parent function. That moves it left 1, that moves it up 3. And so we forgot last time to talk about domain and range. So what is the domain of this function? It's not all the reals, okay? The domain are all the possible values that you can put in for x. So it's easier to think about what you can't put in. So what numbers can you not put in for x? Anything that makes the square root negative, right? So what's the smallest number you can put in for x without going negative? Negative 1. So that means that x has to be greater than or equal to negative 1. And if you look at the graph shows that. If you look here, this is my beginning point or my minimum value, and the graph only goes for x values negative 1 and greater. It doesn't go to the left. Okay. Yeah. X is greater than negative 2? No, because negative 1.5 is greater than 2. So you're forgetting about all those numbers in between there. Yep. So that doesn't really work because you can't pick a smallest number. You can't pick a number closest to negative 1 because there's always one closer. I know, that's kind of deep. You can't be like, could we put x is greater than negative 1.00000000001? Because then I'd say nope, because there's one more closer, negative 1.0000000000001. Whoa, hurting my brain. All right, so what about the range? What are all the possible y values? Well, the smallest the y values can be are 3 on this one, right? So the range is going to be y is greater than or equal to 3. Well, it's not 4 because this is, it goes all the way down to that height, right? That's 3. Oh, no. The smallest value for y is 3. What? Shh. Hush, 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 hush. Huh? Oh, you're good? Okay. So the range is what are the possible y values, and the possible y values are going to be anything greater than or equal to 3. So this graph goes forever. It goes forever to the right and forever up, and it just keeps going and going and going and going and going. So there will be an output that continues to increase all the way to positive infinity, like that way, and you can put any value in greater than 3 that way. Okay, keep trucking here. Now we're going to talk just more in transformations form, not as much of a table and value thing. So this is where some of you like to put the stuff grouped with the y. So if I group it like that and make it transformations form, it's going to look like that. And then you can state your transformations, and this one would be right 3 and down 1. make a little sketch. So you go 1, 2, 3 to the right, down 1. There is your it's like your vertex or your starting point. And this one is going to be just a normal one, so just make a little sketch like that. State your domain and range. My domain is going to be x is greater than or equal to 3, and my range is going to be y is greater than or equal to -1. Because that's how far, -1 is how, like the minimum y value. No. Kind of. It kind of is. Because, well, down 1 is actually like a -1, you know? So. Okay, the next one over here, this is going to be, I'm just going to look at this one and interpret it without moving everything over. So +1 on the horizontal means it actually goes left 1. So it's the opposite inside there. +4 on the outside means it actually goes up 4. And there's a divide on the horizontal, so it's a horizontal stretch. So it's going to be a less scary roller coaster graph. It's going to be flatter, not as tall as fast. And then a negative with the x means there's a reflection over the y. This one's a little tricky because if you think about it, the square root, you can't have a negative inside the radical. And so if it's dividing by a -2, then that means that this top stuff has to be negative because you need a negative divided by a negative to make a positive inside the radical. And so that's why when you graph this one, it's reflected over the y and it's flipped from right to left. So this one's going to go left 1, up 4. It's going to have our little kind of vertex point right there. It's going to be a horizontal stretch, so it's going to be not as tall, and it's reflect over y. So reflect over y means if I graph the parent and the parent looks like that, this one's going to be flipped over to reflect over y on that axis. So it's going to go like this. So you kind of reflect the parent first, then you move it left and up, and then you draw it not so tall because it's horizontally stretched. So now the domain for this one is going to be x is less than or equal to -1. So the domain does get a little bit moved around sometimes, right? If there's negatives involved. And then the range for this one is going to be greater than or equal to 4. Yay? All right, and then the last question, oh, two more ones. This one's working backwards, so now here's what happened, write an equation. So I like to start with, I guess we'll just start with the y side. So it's going to go down 6, I'll pick that up. So down 6 means it's a y plus 6 on the y side. Stretch by 3 on the vertical. Okay, so that means that this y side is divided by 3. On the x side, we're going to go left 6 and compress by 8. So compress by 8 is 8 times, and left 6 means x plus 6, and that's all inside a radical. And reflect over the x-axis here means there's a negative with the y, so I make that stretch a -1. So just working backwards. I like to solve it all for y when we're all done. So y equals, put that -3 over to the other side. That's out in front of the radical. 8 times x plus 6. And then instead of a plus 6 on the other side, I have a minus 6. What do you say? Going pretty fast. I mean, I teach this, so, you know, it's kind of like... You want me to elaborate on anything? Okay. Okay, let's wrap this up here. Sometimes I'm like Darth Vader, yeah. So this is when we wrote the equation given a graph. We had a like the starting point, which in this case a lot of times we had the vertex. So kind of our vertex point, 1, -5. That means that we went 1 to the right. So that is x plus 1 on the graph. And then the y stuff is -5. So over here it's like a y plus 5. Yeah? Then the other point, I don't know if you remember, hopefully, but we plugged this other point in. So we put 3 in for x, and we put -4 in for y. And then we evaluated, so -4 plus 5 is 1. And that equals 3 plus 1 is 4. Square root of 4 is 2. Wait, have I been screwing this up all day? No, I haven't. I just screwed it up right now. It's a -1. Sorry. It would have been cooler if it was a +1. It would have worked out easier. But so inside here, it's actually x minus 1. I don't know if any of you guys were thinking that. Because if they're grouped together, they should both be opposite. So -1 there, and a +1 there, and a -5 there, and a +5 up there. So now we get a we get a 2, square root of 2. So now, does 1 equal the square root of 2? No. So how do I get them to be equal? I have to multiply the left side by the square root of 2. And that's this is like my scale change. That's my stretch or compress value, right? Because up here, this function doesn't have a stretch or compress yet, but we just found it by balancing the sides out because it was imbalanced. So now really this is like times the square root of 2 over here. And so if we clean that all up and move it over to the other side, we're going to have y equals 1 over the square root of 2 times the square root of x minus 1. I don't know why I put those parentheses in there. And then -5. Some people might say, rationalize the denominator. So then rationalize the denominator, I get root 2 over 2. And then square root x minus 1 minus 5. That'd be your best top dog final answer. Yeah, all right, 23 minutes. That's been about where we've been at every day. So that's pretty decent. Got cut off there. Here's your assignment. There you go. All right.